Essentially, edge networks are kind of an evolution of CDN. Like, basically, speed, latency is very important to the web and web app. Google has all the data. If your website loads in 3 seconds instead of 1, you lose like a third of your customers. If it's 5 seconds instead of 1, you lose like 90% of customers. Crazy statistic. Amazon says for every 100 milliseconds of latency added, they lose 1% of total sales, which is $5.7 billion a year for them. Everyone's kind of trying to get their apps and their websites or whatever it is to load as fast as possible because they see what an impact loading times and latency have on which apps people use, people return to, people buy from, etc.
Welcome back to the podcast. Today we have the pleasure to discuss Fleek with Harrison, who is the co-founder. Thank you so much for joining the podcast.
Yeah, thanks for having me. Excited to chat.
Could you tell me a bit more about your journey and transition from Web 2 to Web 3? That's always the question that I start with. I probably should change at some point.
Yeah, no problem. I entered the space in like late 2016, where I started a project called Token Foundry out of Consensus, which was kind of like the token arm of Consensus, helping projects with token sale infrastructure, trying to do things in like a regulatory compliant way. But right before that, I was doing something very similar in Web 2, where I had helped build a project called Seed Invest, which was essentially like an equity crowdfunding platform that was trying to do like more, equity raises in a crowdfunded way, relying on the Jobs Act, which was supposed to enable like real crowdfunding, but the regulations ended up being very I'd say unfriendly, and so that industry didn't take off the way it was supposed to. But then when I saw Ethereum launch, and the first use case that was really taking off was these sort of like decentralized, crowd sales essentially, that's where I got the idea to try to build a business like that on Ethereum. And so that's kind of how I got into the space and where I started. And then I did that for 2 years, and then basically realized I was way more interested on the decentralizing the web narrative than decentralizing Wall Street narrative. And so then that's when I left at like the end of 2018 and started Fleek.
Could you tell me a bit more about your experience in Consensus and what are the skills that you acquired, the main 3 skills, let's say, that helped you build Fleek and Fleek Network? But also, just a second question is probably to clarify the difference between Fleek and Fleek Network.
Yeah, no problem. I'll start there. And so you could think of Fleek and Fleek Network in a very similar way to like Helium and Helium Mobile, where like you have the Helium network, and that's like essentially the infrastructure and the protocol. And then they have Helium Mobile, which is this product built on top of some of the infrastructure or the protocol that they leverage as a distribution advantage to drive usage to the protocol. And so similarly, you could think of Fleek Network as like the Helium network equivalent. That's the decentralized edge network. That's essentially like the, decentralized Cloudflare in a way, where it has all these performant web services that can be built on top of it. And then the Fleek platform is kind of like Helium Mobile, where that's like just a modern developer platform, essentially like an open source cloud platform with seamless DevX that's surfacing a lot of the functionality and infrastructure of the network, but packaged into a very user-friendly or developer-friendly and familiar developer experience, and just, similarly, like just trying to build better web services, leveraging our decentralization advantages, and just sort of presenting those to developers so we can, position it as a viable alternative to an existing cloud platform like a AWS or a Cloudflare or a Vercel. So that's like Fleek is the product, and Fleek Network is sort of, and like the UI, and then Fleek Network is like the infrastructure layer. And if you look at most cloud platforms, they're pretty similar. Like you have the actual physical infrastructure layer, and then you have all these abstraction layers built above to really, provide a nice experience and drive usage to that underlying infrastructure. And so we feel that if you want to disrupt a big cloud and build a decentralized cloud, you kind of have to approach it the same way. And so that's kind of, where the two pieces of the puzzle come in.
And to bring you to my first question is that what are the skills that you hone during
Yeah.
your Web3 experience in general, and mainly the essential skills that helped you develop and build Fleek?
Yeah, so I'd say, consensus in the 2017 timeframe was a really just special place. I probably won't have another experience like that, and I think a lot of people who were there during that time feel the same. But I think just I learned a lot from Joe in just the way he approached building the company, how much he didn't just talk about decentralization, but really lived it with the way the company was structured, and sort of how everything at Consensus worked. It was very true to the ethos of Ethereum. But I would say I also learned, some of the downsides of that approach. And so in all these experiences, Consensus, building on Filecoin, building on the internet computer, like I'd say the one common theme, and I think you see it with existing other protocols as well, you learn a lot more from what other projects or companies did wrong than you do from what they did right. And so I'd say a lot of what we're seeing with not just Consensus, but Ethereum in general, is like there is sort of a trade-off between decentralization and like efficient just product or infrastructure building, and just like being able to move quickly and things like that. So I'd say I learned a lot. That experience was awesome, and yeah, that's sort of what led me down the path ultimately to Fleek and Fleek Network. So yeah.
You touched upon a very important part that everyone is struggling with, and it's very related to the blockchain trilemma. But it's just this idea of something being efficient and or decentralized, and a lot of L1s are struggling with it because if you have comparatively high requirements for validators, then it will be comparatively centralized because not as many people would be able to become validators, and that's the problem that Bitcoin has been having with the miners. Like every after halving, we see fewer and fewer miners. So how do you guys resolve that problem of trying to stay efficient, or as efficient as possible, but also as decentralized as possible?
Yeah, I think, well, we've done several things, and that's really, where we saw a lot of the innovation coming out of the smart contract side of the ecosystem on like how can you build high throughput scalable blockchains. And those are a lot of the ideas we just applied to a web infrastructure use case. And so there's a few ways you kind of handle those issues. One is like, if you use a DAG-based consensus, which is what we use Narwhal and Bullshark, which is what the SWE and Mistin Labs team essentially created. So you don't have to come to global state. So that allows you to alleviate a lot of the issues these sort of like Gen 1 blockchains have, where every node needs to come to consensus on everything before advancing the chain. But another thing we do is we take a stateless approach, which is where a lot of the newer and high throughput blockchains are going, where you eliminate one of the biggest issues plaguing these Gen 1 blockchains, which is state bloat. Now, for a smart contract platform, you need state. So you just have to figure out the most efficient way to deal with that, or to shard, or take whatever approach you think is best. But for us and our protocol, that's actually one of our biggest advantages, is we could be pretty much stateless. Because with the type of web services we're focused on, CDN, serverless compute, you're not storing data. Usually you use an external data source or origin. That could be, S3, that could be a database, that could be a smart contract platform, it could be anything, pretty much. But so we don't guarantee persistence. We cache data like a CDN or an edge network does, but so popular data will be on the network, but if that data isn't popular anymore, it'll fall off, and then just next time it's requested, we'll just go fetch it from the origin again. And so that's the beauty of sort of this modern approach to building web services and this more like CDN type approach where you're more stateless and you don't have to worry about data storage. That's what enables our nodes to be a lot more performant and agile. And then I would say, like on the Bitcoin issue specifically, well, it's different. It has to do with the incentives of the network. At the very core of any network is the incentives, because that's what's making everybody in that network behave a certain way. And so with the way their incentives are aligned, it sort of leads to that issue where it becomes less and less profitable for a miner to mine, and so you naturally get this sort of centralization. But the beauty of an edge network is it's sort of like Uber in a lot of ways. Like the work is very regional. So a node in California is mainly only serving requests to users in California. A node in Korea is mainly doing work and serving requests to someone in Korea. So so essentially, like as we add more nodes to the network, which is one of the beauties of these DAG-based consensuses, the throughput of the network actually increases. So that's the beauty of these more modern approaches to building these high throughput blockchains, is rather than more nodes to the network slowing down the network or leading to centralization, you actually have the opposite effect where adding more nodes to the network will just lead to higher throughput and better decentralization without impacting performance. So, yeah.
There's a lot to uncover there, but just to bring you back to the DAG-based consensus, so my understanding of it is that essentially each transaction is verified by the previous transactions, but there are some like technical issues that I am aware of, and one of them is like the double spend, because the canonical chain is not long enough to ensure that you have enough verifications that the following transaction is actually correct. Is that something that you're concerned? I know that it gets a bit technical, but I'm really interested in that.
I'm sure in a smart contract use case, it's a concern. I'm sure SWE has good answers to it. Sounds like Solana has answers to it as well. But that's the beauty of Fleek Network, is like we don't have smart contracts. So we're not dealing with like financial value here. So the types of transactions our blockchain is confirming is essentially we have these delivery acknowledgements. So every time a node does work, whether it's serving a bandwidth request from the CDN or doing a compute job from Fleek functions or whatever it might be, they essentially generate this delivery acknowledgement. It's essentially like a ZK snark. And so periodically, all the nodes are doing is rolling up the proofs, like those delivery acknowledgements, to the protocol. And so all our core blockchain is doing is collecting these proofs from the node operators and verifying them and appending balances accordingly. Because on each delivery acknowledgement, it knows, whose account it was. And so we have a prepayment model. And so the way we get around that is like, if your balance, no different than how a cloud platform does it, to be honest. It's like if your balance drops below a certain level, then nodes might not do work for you anymore because they might be afraid that, by the time everyone submits delivery acknowledgements, there might be a chance that they don't get paid for the work provided. But we could also have a reserve, pool that, covers instances like that. But the way we solve it for now is we just, once your balance drops below a certain amount, that work for your account wouldn't necessarily get done anymore. And on the Fleek platform, we abstract all that. So like it wouldn't necessarily be even something known or something a developer needs to concern themselves with. But if you're using Fleek in like a self-hosted way and you were just connecting to the network directly yourself and using your own stablecoin balance to pay for your usage, you would just need to know, and just like you do on a cloud platform, like, okay, I should keep a balance of, based on my usage and how much I'm spending on average in a week or a month or whatever, I should keep this much and I should replenish it at these levels to make sure like I don't run into any issues. So yeah, it's less of a concern in our use case because like we don't necessarily have financial value and a double spend problem. Our problem would just be like maybe someone was continuing to consume services of the network without having an active balance. But that's a much easier problem to solve, and yeah, you could just put in delays and account minimums to make sure you don't run into issues there.
Nice, and I guess that leads us into the use cases, but before we get there, I kind of want to unpack this idea of like decentralized edge networks because you've mentioned it a few times. But could you give me the TLDR and why it has been gaining popularity? And I guess it would be a very nice transition for us to discuss the idea of DePIN and what has happened this particular cycle.
Yeah, for sure. So essentially, edge networks are kind of an evolution of CDNs, where basically like content delivery, like basically speed, latency is very important to the web and web apps. Google has all the data. If your website loads in 3 seconds instead of 1, you lose like a third of your customers. If it's 5 seconds instead of 1, you lose like 90% of customers. Crazy statistics. Amazon says for every 100 milliseconds of latency added, they lose 1% of total sales, which is $5.7 billion a year for them. So everyone's kind of trying to get their apps and their websites or whatever it is to load as fast as possible because they see what an impact loading times and latency have on which apps people use, people return to, people buy from, etc. And so CDNs did a great job in caching content in multiple. It's not too much different than physical distribution. Like you have regional distribution, and those people handle distribution and do the work in those regions instead of having one place do it globally. So CDNs are not much different. Instead of storing all your content in one AWS US East server location, you cache it in different regions. And so now this way, when a user in that region requests the content, it's a lot faster because it's coming from somewhere way closer to them than just US East data center location every time. So now with the success of that, it also is much cheaper to use a CDN and serve content from a CDN because you're grabbing it from memory instead of storage. So that's where those became very popular. Now with Edge Network,
could you elaborate on this? I'm not 100% sure that I get it. What's the difference between grabbing it from memory than grabbing it from storage?
It's just a lot quicker and easier. And also egress costs. There's a lot of things you get charged for from a storage product that you don't when it's coming from cache. So that's essentially like where CDNs are great is they save you a lot on those egress and ingress costs. So instead of pulling it from storage every time and then getting charged those costs from like S3 or wherever you're storing that data, essentially if you do it from a CDN, the cache costs and the gigabytes, like what you're paying for a gigabyte of bandwidth, is way less than usually your egress or ingress costs. So that's really where the cost savings comes in. But essentially, so edge networks are now, like people are saying, oh wow, CDNs work so well. Are there other parts of my stack or infrastructure I use to power my app that I could do this same thing with? So that's where serverless functions and more serverless compute and edge compute and there's edge databases, there's edge storage, essentially just growing on that concept of doing the work closer to end users in multiple geographic regions rather than just doing everything in one place. It's also a security advantage because instead of having one server someone can attack, you've got, 30 or 50 servers that, you don't have a central point of failure. If one gets attacked, you still have many others that could do the work and keep your app up and running. And so that's really why everyone's, like, the big trend this decade is moving to the edge. So, like, moving to the cloud was the big thing for the last 2 decades, and now everyone's moving to the edge. Really all that means is they're moving to a more, geo-distributed, optimized architecture with more of these stateless components, so that they could run more of the infrastructure in more locations closer to the end user and reduce those load times and latency.
And I guess that leads to the next part of the question, which is like the DePIN component, which is like a decentralized physical infrastructures. And I normally associate it with this edge devices, but adding the Web3 component to it and introducing tokenomics, incentives, visibility, security, and all those additional features. But just to take a step back, DePIN was invented in like 2021, but it didn't gain as much popularity. But now everyone is talking about it, and it sounds like it's one of the dominant narratives, and everyone is excited about it, especially with like Helium, Hive Mapper, as you mentioned earlier on, and there are a lot of like GPUs. So do you have a theory, or are you thinking about why it gained popularity in the last, I would say, 6 to 10 months? What was the trigger? But also, could you just talk a bit more about this additional component of blockchain to the edge devices, and what are the benefits of it?
Yeah, so, basically I think DePIN is just a natural evolution and next step from what, like, Uber and Airbnb started. Like, those are essentially centralized physical infrastructure networks. Like, and they essentially used incentives and, like, economic incentives to build basically a decentralized network of drivers, for example. And by decentralizing the supply side, they were able to unlock, like, efficiencies that you just can't do in a corporate setting. Like, if they had to go get all those cars, buy those cars, deal with all the jurisdictional, regulations, hire people to manage those drivers, it just wouldn't have ever been economically feasible to do that in a corporate structure and centralized setting. And that's actually very similar to edge computing. Like, if you look at edge computing in Web 2 right now, it's really like we've just gone from 1 server to like 30 servers, because most of the edge platforms are just sitting on different AWS and other cloud platform data center locations, because it's not really economically feasible for them to go set up these edge, node in all these different locations, get the hardware, get people to manage it, secure it, deal with all the different regulations and all the different jurisdictions. It would be way too expensive and take a long time and probably cost way too much. And that's why a Cloudflare only has 300 POP locations, because if they add another 300, they can't charge double, so they're just adding costs and overhead with no real clear benefit. So everyone in Web 2 has kind of reached this, like, good enough level, and they're all in price competition already. So, like, it's like it's not really feasible for them to do real edge computing. In the same way, it wasn't really feasible for a centralized, like, cab company to go hire and handle all these cabs globally. But by decentralizing the supply side, you could actually make it work. And so for edge computing, it's pretty similar. So, like, when you decentralize the supply side, you could get way better coverage in a way more economically feasible way by allowing all these independent operators to basically do it for you because of the economic incentives. The same way Uber drivers decide to drive for Uber because they want to make money. So I think where blockchain comes in is really just because when you build these centralized physical infrastructure networks, you're at odds with the operators of your network, because you're trying to take as much of a cut of the pie from them as you can because of corporate profit pressures and other just corporate nonsense. And so you end up kind of on the other, you're not on the same team as your drivers, basically. There's a lot of drivers who I think don't like the current setup with Uber and how things work. So I think using a blockchain to coordinate a network like this in a more like decentralized way, and just blockchains are great for coordination. It's taking what Uber and Airbnb have started to a next level that actually creates additional efficiencies and additional just benefits in terms of aligning the participants of the network better, actually allowing those operators to share ownership in the network rather than be like, sort of a service provider to the network. And so, like for edge computing specifically, it's a perfect use case of DePIN, because where a lot of networks, if you look at them, they look like an edge network. Like their topology looks like Cloudflare. They've got all these nodes in all these different geographic locations, but none of them are actually like geographically aware or optimized. And so it's a big waste. So like, most protocols are just trying to leverage decentralization as a security advantage. What we're doing is actually leveraging it not only as a security advantage, but also a performance advantage. And so for a lot of the same reasons, an Uber could get you a car faster than a cab company. They got more cars in more locations closer to the end user requesting the car in more instances. That should be the case for Fleek Network as well, where we'll have more nodes than a Web 2 edge or CDN. So we should have, in cities like New York, where AWS has a data center or something, performance would probably be comparable. But everywhere outside the big cities where they have data centers, we should have a node closer to the end user requesting, whatever it is, the website to load, scrolling Instagram, whatever, in more instances. And so that's where we think we have a performance advantage over Web 2, because we'll have better coverage. And then on the cost side, when you run a system like this algorithmically and reputationally, like what Uber does, instead of the way a centralized cloud or cab company does, 75 to 80% of IT costs are human attributed things. And so if you could eliminate all that human bloat and just run a system like this algorithmically, then you should be able to get the costs way closer to the hardware and electricity and internet costs. It actually, like the cost incurred to provide these services. And we've already seen other bare metal networks get up to 80% cheaper than cloud alternatives. So we think, DePIN essentially enables us, and decentralizing the supply side, we should be able to compete or potentially be better than corporate clouds on performance, definitely on cost. Open source, which we think is becoming a bigger and more important factor for a lot of use cases of web infrastructure. Verifiable, and like just as good DevX. That's where the Fleek platform comes in, and no corporate nonsense. So that's all the permissionless, censorship resistance, all those benefits. And so that's where we think, we could actually build a product that is useful and has value, not just to Web3 developers, but to all developers, and go after the much larger Web2 developer market. But to answer your question about why I think DePIN sort of came on strong this year, I think because it's actually starting to prove itself. Like Helium is starting to show like early signs that, DePIN is actually like a better way to build infrastructure networks. There's a lot of other newer networks that are starting to show the same for different use cases. And so I think, it just, it was a lot of things, I think, that also just over the last few years, you've had this new category of like, I wouldn't say investors, but they kind of are investors. You have this new class of node operators as a business, where instead of investing capital, they're essentially investing hardware towards new networks that they think they can make a financial return off of by providing the services the network is offering and earning the economic incentives and rewards or payment that they get for providing that service on the network. And so now, I think 3 years ago, it was a lot harder to bootstrap the supply side and get enough infrastructure operators around the world that you would need to go build a use case. But now, because people realize that it's a good business opportunity, you've had this explosion on the supply side of people with bare metal hardware looking to do this. And so it makes it much easier and more feasible for a new DePIN concept or network to come to market, now that what historically was the hardest part of the equation is much easier, and like you don't have to worry about nearly as much. So yeah, definitely a combination of timing, tech to build scalable protocols and high throughput, protocols that could support various use cases that require high throughput and performance, going beyond just smart contract platforms. And yeah, just I think seeing real revenue from these DePINs.
We covered quite a lot. So in my head, I now have a decent understanding of the underlying layer, which is the Fleek kind of not blockchain, but just the layer, and then you have the network, and we have a good understanding of like the DePIN and the entire infrastructure. But could you tell me a bit more about the client side and the provider sides on the Fleek network, and if you can have any numerical data to provide, and to mainly illustrate the interest on people utilizing the services the blockchain company provides over the traditional companies, that would be very interesting for me.
Yeah, so I would say the usage we have now is all like largely on the Fleek platform, and what we're doing is essentially we start slowly migrating our own Fleek infrastructure, as well as like the infrastructure powering our customers' sites, over to the network. We do it in a sort of slow and phased approach because we don't want to mess up the reliability of anyone's production apps that are hosted on Fleek. But for example, like if you think about what makes up the Fleek platform, it's a lot of Lambda functions, it's a lot of Cloudflare CDN usage, Cloudflare workers, a database. So all those things, now we have a CDN service on the network. We've got a serverless function service on the network. We'll continue to keep building out additional services. We just added new SGX capabilities to the network, which open up a lot of cool opportunities to build like verifiable web services. But so essentially, like the Fleek platform offers traditional developer web services and infrastructure, and like most of the building blocks they're using to build apps today. So hosting, a CDN, serverless compute, things like that. And so essentially, like that usage, and as we continue to add products and features to the Fleek platform, those are all either powered by Fleek Network under the hood or augmented by Fleek Network. For example, like since we don't store data on the network, next month you'll be able to basically choose any storage layer you want on the Fleek platform, but then Fleek will be used as the CDN, Fleek, to sort of accelerate that content. And so, yeah, I think there's like 75,000 apps or sites hosted on Fleek today. But let's say, a lot of those are staging sites or hackathon level project. There's probably like 5,000 to 10,000 real apps and projects using Fleek for hosting. But the exciting part is we gained all that usage just on IPFS hosting. Now, like, we have Next.js app hosting coming in 2 weeks, and like real infrastructure covering more of the full stack. But we could use this platform and initial user base we built as a foundation to now, add these new, more full stack capabilities and support way more interesting use cases to offer developers, and not just the Web3 devs offer like interested in IPFS hosting. Now we could offer like just real hosting, real, serverless functions that even a Web2 developer who just, is looking for a performant, low-cost, open-source Vercel alternative or Cloudflare alternative, we could start to like, offer value to them as well. So that's sort of, I'll pause there in case you want to, yeah.
I just want to ask about future announcements and further developments, because you've been working on the network and it sounds like you've developed quite a lot. But what's the ultimate goal? And could you just run me through the roadmap and what you're hoping to achieve?
Yeah, so basically the core protocol will be done in like November. That'll be like the V1 of the protocol we go to market with. So once that's done, that's when could really shift focus we'll always still make more improvements and stuff to the core protocol, um, and add new, resources and core components. But what's really exciting is the service layer. So you could consider that like the smart contract layer for Fleek Network. But instead of building like an AMM or a lending protocol, services on Fleek Network would be more like web services. So a CDN, different flavors of serverless compute for JavaScript or EVM or Rust or whatever language or runtime you want. Node.js, Bun. It could be like all sorts of web services you could build with these new SGX capabilities to build verifiable web services. Like if you look at almost every Web3 stack, it's like some combination of Lambda functions or CDN or different things. So so essentially that's the play here, is just continue to build like more traditional web services, leverage the benefits the decentralization, the blockchain approach gives us to just offer better or just as good alternatives for these popular developer use cases. So like Next.js app hosting. If you look at most other protocols, like they kind of take the approach of building the network and then hoping third parties build like the products and the use cases on top. So like they might stop at the point of releasing Fleek functions. But what we do is now with the Fleek platform, we see this new infrastructure coming to the network. Now we can package it into new products and use cases that leverage that infrastructure that will really help drive distribution to the network. So for example, with Next.js app hosting, all the server-side rendering, all the image optimization, all the incremental static regeneration, all that middleware type stuff, that's all running in Fleek functions. But so now, instead of just offering infrastructure, we're actually offering a product and a use case to developers. And since we're known as a hosting platform, it fits very seamlessly into our product and our user base and our roadmap. So the roadmap for the network is like, just continue to add new services. We've got a lot of cool services planned for the network. Eventually, we'll open it up for third parties to be able to develop at the service layer on the network. So you could build all sorts of, roll-up infrastructure, AVS infrastructure, because like a lot of, like all these decentralized middleware or decentralized web services, like right now they're all forced to build their own node networks, and it's hard and it takes a long time and it requires a lot of specialized skills to build your own node software and deal with consensus and networking and all this stuff. Now, like the same way you could rent economic security from Eigenlayer, you could just rent your, edge optimized node infrastructure from Fleek Network and basically just outsource the infra the same way an L2 can do it compared to an L1, alt L1, and that's why I think you've seen such a dramatic shift towards L2s instead of alt L1s, is now you could just not deal with infrastructure, not deal with DevOps, not deal with any of that low-level stuff, just build your product, your platform, your, focus on your core logic and outsource the rest, essentially to Conduit and Ethereum, and you get basically the same guarantees and everything as being your own L1, but it's much cheaper. You don't have to pay out all this inflation. You get all the benefits of being your own chain without 90% of the headache and the work and the time to get there. So I think with Fleek Network, that's really, where to the Web3 community it becomes interesting, because everyone's using Cloudflare in their stack, everyone's hosting on Vercel, everyone's using Lambdas or workers or some form of serverless compute. So now we could just offer just as performant, much lower cost, open source, more Web3 aligned alternatives to build parts or all of your stack on. And then on the Fleek platform, as the network continues to add more and more services and functionality, the platform will just continue to package it into features, use cases, new products that are applicable to developers. So, we have plans for a database next year. Like we have a lot of cool web services we're going to build on top of SGX for name servers or DNS, and really be able to offer true decentralized front-end hosting. So that's kind of the playbook. Not too much different than a normal cloud platform on the Fleek platform side. Just continue to add new features and functionalities powered by the network that we think help solve real developer problems, or provide real viable alternatives to other infrastructure they're already using.
And you mentioned a number of projects are building on top of you. Could you mention some of the most interesting projects? But also, I'm really interested in the projects that are available and have the opportunity to build only on Fleek and they couldn't build on any other L1 or any other blockchain, or let's say it's more beneficial for them to build on Fleek than any other blockchain.
Yeah, I would say so. Most of the existing Fleek usage is just for the IPFS hosting. We do have like maybe like 600 or 700 Fleek functions deployed now. But that product's still in alpha, so we tell people don't use it in production. The Edge SGX product is a few weeks old, but we're already starting to see some interest and some playing around from other protocols who need SGX or TE capabilities, and they don't want to spend months trying to integrate it into their own stack. It's very hard. The DevX is pretty miserable. You got to deal with hardware and Intel and all these things. And so now with this, you could just use an API, add TE capabilities to your app in a few days or a few hours if you want. So that's kind of the benefits we're going after. But there's a lot of AVSs where you could probably build those fully on Fleek Network. Like if you're just an Oracle or you're just a proof generation, like you probably don't need your own siloed node network and all these things. Like no one in Web 2 who builds SaaS builds their own infrastructure. They just rent it. And so that's where we're seeing interest from protocols who are realizing, hey, I could offload parts of my own stack to Fleek Network, to Fleek Functions, to the Edge SGX product, to the CDN, and uncomplicate my own stack and allow me to focus less on infrastructure and more on the things that make my product or use case or web service unique.
And could you run me through that experience? I'm sorry to interrupt. I'm really interested in the idea of let's say I'm a developer and I would rather use Fleek than just do everything myself. Could you run me through that experience and how are you simplifying it? Because I don't think that I fully understand it. So if you can clarify for me, it would be very useful.
So basically, it would be the exact same experience as if you tried to, build this on AWS or Cloudflare or Vercel. Like, if you look at most of these nodes, it's essentially just running on AWS and using underlying web services on AWS under the hood. So really, it's not like we're telling you to do, but because it's on AWS and it's centralized, you yourself have to do all the consensus, the networking, the P2P to let your nodes communicate with each other. On Fleek Network, that's already built into the infrastructure. So now you could build web services like you would build Web 2 web services, but they're actually, already got all those decentralization aspects added because it's built into the infrastructure layer. So the idea is you come to the Fleek platform, it's the exact same experience or better than AWS, and Cloudflare, but hopefully on par with Vercel. Vercel has great DevX, so we just want to be, as good as them. We're not, necessarily they're the best of the best. So, we don't need to beat them. We just need to be in the range of as good as them. But that's the idea. You could provide a developer experience for building apps, and now with Fleek Network, we could offer more of a full stack suite of products and services covering not just front-end hosting, but actually, the back-end Lambda, equivalent or, SGX infrastructure. Like I said, we're building name servers. We have a plan for a database, things like that. So you could use more and more of your infrastructure, leverage the benefits of this decentralized approach and, the sort of edge network, but just build in a normal Web 2 where you don't have to think about, all these lower level, Web 3 primitives that are required to build, decentralized web services. So it's same as L2s. You could deploy a roll-up on Conduit in a few clicks. You don't have to worry about, anything. And so that's really where we think things are going to go. And especially for web infrastructure and web services, it's you just got to get that experience as familiar and easy as possible, abstract all the hard, complex parts, and just allow people to build apps and web services and, in the way they're used to. And now you can go after a much bigger market of developers where these benefits should resonate with almost anybody. So yeah, but like, if you want to build directly on the protocol, there's a CLI. The experience is very similar to, what you would expect building on another cloud platform. The only difference would be like your payment is in USDC and you need a wallet. But if you don't want to do those things, you could just use the Fleek platform. That's all abstracted, and you could pay with a credit card, and we'll just facilitate the payments to the protocol for your usage under the hood for you, and kind of just abstract that whole part.
And we've been talking a little about the edge network, and I guess one of the criticism against it is that it's fully decentralized. So it's very challenging to ensure that all the node operators are held accountable, because that's normally the issue, one of the inherent issues with decentralized systems. And we have arguments like this within like the Ethereum ecosystem. If you have something that's like fully decentralized, do you implement like a slashing mechanism to ensure that people commit and execute the tasks? So how do you deal with it? Because you were saying that you have essentially nodes all over the world, and I'm really interested in the slashing mechanism and the incentives, because I know the next question will be about the incentives and the tokenomics and how you incentivize them through tokens. But at this part, I'm really interested in the slashing mechanism and how do you prevent them, or actually how do you ensure that once they commit to a task, they execute it?
Yeah. So it's a good question, and I'm glad you asked. So basically, we handle this in a few ways. Number one, we try to handle it cryptographically, or like do it where you can't misbehave essentially as much as possible. So for example, the whole network is Blake3 hashed, which is like essentially a form of content addressing. It's IPFS compatible, but it's kind of like a newer hashing algorithm that's a lot more performant, and it's very cool. But because of some of the Merkle tree structures it uses, and there's definitely something more for the technical folks on the team. But what I can say is all the bandwidth on the network is verified, because even as it's streamed, with the way Blake3 works, you can essentially know if if a piece of data belongs to the parent file or piece of content you're requesting. So on the bandwidth side, it's hard to cheat. It's almost impossible. On the compute side, it gets harder. So the approach we've taken is by default, the compute is not verified. And the slashing and economics of the system could be enough where, like, if you're just, calling an API to get the weather for, a simple weather Web 2 app, there's probably not much incentive for a node to cheat. Because like I said, like, we're not dealing with financial data and value. So for a lot of compute use cases, if you just wanted the cheapest compute possible, you could do the unverified default version. If you want higher levels of guarantees, you have many options. Number one is you could use the SGX capabilities we have. So now the node, basically they can't see your data, they can't, cheat. Basically the results are verifiable because you're trusting the hardware. But Fleek Network is VMless, so you could build a ZK service on Fleek Network. You could build a simple consensus-based compute setup. So let's say you didn't want to trust the unverified single response. In 2 lines of code, you could say, okay, I want to ask 5 nodes to compute this. And I want to, if all 5 match, great, give me the response. Now, what's cool about Fleek Network is we could grab all those responses in parallel. So you wouldn't actually impact performance if you wanted higher levels of guarantees by asking multiple nodes. So like, that's sort of like the internet computer does a consensus-based compute scheme. So they have 12 nodes in a subnet, and they all compute everything, and then they come to consensus on it, and then they return the response. So that's why they can't get your response in 2 seconds, for 2 seconds, because that's how long their consensus takes. But with us, we basically leave it to be developer's choice. So if you want to customize your own consensus-based compute scheme, you could do that. So if you say, okay, I just need 5 nodes, or I just need 3 nodes, and if all 3 match, give it to me. If all 3 don't match, ask another 2. That's all stuff you could program. We'll have preset configurations in the Fleek platform to make it very low cognitive overhead to give you options based on cost and verifiability. But that's the thing, is let it be open and developers' choice. So we have plans to build a ZK service, plans to build an FHE service, plans to build all these types of verifiable compute. But in the network, what's also cool is, similar to like Cloudflare or another Web 2 cloud platform, if a node, like, all the work is allocated based off of latency and a performance-based reputation score that's built and modeled off of eigentrust, which is an algorithm. So all the nodes are constantly scoring each other in a way that's very Sybil resistant. And so if a node doesn't respond to a request, the network would know immediately, and it would just send the request to another node nearby. And so if that node was offline, something happened to that node, after a few bad requests and no response, it would just be off and not get any work until, it put itself back in good standing. And so it's a lot like Uber and how they allocate work. It's like, okay, ride coming in, who's the highest reputation driver nearby who's not busy right now? And so work is allocated on Fleek Network. So the slashing essentially comes down to, yes, if that node is not online, or if they're caught where they're, sending a response back that isn't the response required. In the unverified compute model, you would not be able to catch that. In the consensus-based compute model, you would. And so that's where we kind of use the network. We also have a warm-up period for nodes. So we approach it in several different ways. But yeah, the slashing is really for like severe penalties of like doing something malicious or, being offline or something like that. Offline, you wouldn't even get slashed. You just wouldn't get work allocated even. So it's really when you do something like really, really malicious, all the other things can be handled essentially at the layer above the protocol, and allow the developer to choose essentially their level of security verification, and we could just build some preset templates so we make it easy for the different use cases and what works best.
And could you tell me a bit more about how can someone become a node operator? But also, just to summarize what you were explaining, my understanding is that you essentially have reputation-based system, and if you don't deliver on the tasks that you're allocated, the number of tasks that will be allocated to you will essentially decrease unless you improve your score, and based on your score you'll get tasks, which is good enough because there is no financial incentive there. So even if you don't deliver on the tasks that are assigned to you, there's no money to be lost. So that's good enough.
Like the compute job at hand, like maybe you built a sequencer on Fleek Network, and so maybe a node operator would get smart and realize, hey, if I get this, if it's my turn to submit this to Ethereum or something, I could play some games with MEV or something and make money. So if you wanted to do that, you could set up a simple consensus-based like compute system right in front of that to say, I want 3 nodes to submit this, and if the 3 responses are the same, then submit it. So that's what a lot of these provers and sequencers are doing, where they kind of like do an initial consensus amongst different results and then submit that. So that like eliminates the ability for any single node operator to game things. But so yes, in theory, like that is correct. But also, just one thing I want to touch on is like if a node is down, with how fast Fleek Network is in response times, like that user requesting that page to load or whatever it is that the request failed, we would just send it to another node so quickly that the load might take 200 or 300 milliseconds instead of 100, because we kind of have an understanding of how long something's supposed to take. So as soon as we know it's not happening, we would send that request to another node and so even if all the nodes in a region went down, the beauty of Fleek Network is as long as one node is running, the network can run. So if all nodes in a specific region or a data center went down or something, the only thing that would happen is the request might go to a slightly further away node, and users in that region might just get but to the human eye, we're talking such low latency that it wouldn't even be noticeable to the average user of that app or website. And then once the nodes came back online, it would sort of self-heal. So that's what's cool about our use case and the way the network is architected, is even in situations like that where a node doesn't respond, like we have ways where we could pretty much guarantee good sort of service and reliability and not impact production apps, which is that's what you have to do to compete with these Web 2, because that's what they're doing. You know, if a Cloudflare node goes down, you don't know it. They're just using the other 299 and routing, you know, traffic around it until it's fixed. So we basically do the same thing. But to answer your question about how you could become a node operator, so essentially we have a token, and it's a lot like a taxi medallion, where you need it to become an operator on the network. But one thing that's unique about us, I'd say, is we don't have like a free-for-all on the node operator side, because we don't want this problem of like 99% unused capacity. It's just you're wasting money. Like you have all these nodes, but you know, you don't have the usage for them to do anything useful to the network, so you're just paying them for nothing. It would be like a cloud platform renting out 20 data centers before they even have the usage to need one, you know? And so the thinking is we'll probably start somewhere in the 500 to 1,000 node range. So we already have better coverage than Web 2. That's enough. There would be different regional caps, like maybe 200 North America, 200 Europe, you know, 200 Asia. So you can get a sort of, you know, initial geographic distribution you want. And then the top, like whatever the active set is, let's say it's 1,000 nodes, the top 1,000 staked nodes by auction like amount are who the active set is. But then once you're in the active set, all work is allocated based off of latency and the reputation score. So that's why I call it a taxi medallion, because it doesn't actually guarantee you any amount of work. It's just to become an operator on the network, and then from there, all the work is allocated in a way that won't impact performance. And so there is also like a non-node operator staking component, where it's kind of like a VE model where you could stake as a non-node operator, and a certain percentage of the FLK emissions and the USD stable revenue that the node operators are earning for the work they're performing on the protocol goes to those sort of VE, FLK, like just normal non-node operator stakers. So it's a way for someone who's not a node operator to still participate in the upside of the network and, you know, maybe have access to governance and things like that, but not dilute the node operator set and just unnecessarily, you know, bring on 10,000 nodes before usage dictates we need that many. And then as usage of the network grows, we'll look at the heat map of requests, so we'll know where we need to add more nodes as usage starts to approach capacity. So if we see, okay, we got a lot of apps using us in, you know, the US and California, like we could, you know, say, okay, we're going to raise the North America cap and, you know, get more nodes in, you know, the regions where the usage of the network shows we could use them.
And what's the best place people to find you and learn more about Fleek Protocol? I know that you're quite active on X, so tell us your X handle.
Yeah, @Fleek is the like developer platform, like Fleek.xyz platform handle. That one's a little bit more developer focused, but now the foundation has the Fleek_net handle, and I know they're going to start ramping up their own marketing and talk more about the token and, you know, like more Web3 marketing and, you know, like explain the protocol and the token and the opportunities for people to participate, both node operators and non-operator, you know, stakers and stuff. So I'd expect that to ramp up over this month. So I'd say people should follow both @Fleek and @Fleek_net. And that, yeah, is definitely the best place to get and stay updated.
Nice. Thank you so much for joining the podcast and telling us about your project. Such a pleasure talking to you.
Yeah, likewise. I appreciated all your questions, and yeah, look forward to staying in touch.